Hello kiddos, welcome. We're going to start chapter 1 today, Chemistry and Matter. We'll have quite a bit of vocabulary to go over. Hopefully this will prepare you for the assignments that we'll do during the school day. The whole idea of a flipped classroom is for you to be able to watch the lecture at home, take good notes, and then come to class prepared to begin your assignments and experiments that we'll do during the school day. So we'll begin by defining what chemistry is. Chemistry is simply the study of matter. So we'll write that down in our notes, the study of matter, and I'm going to add a little bit to that. So the study of matter and the changes it undergoes. So you may ask yourself, well, what is matter? If we're going to be studying matter, what is matter? And that basically, when you think about it, is the stuff around you. Now I know that doesn't sound too technical, so let me add a technical definition for you. It's anything that has mass and takes up space. So that's the junior high definition. You probably heard that last year, maybe the year before in one of your science classes. Anything that has mass and takes up space. So what is mass? And mass is simply a measurement that reflects the amount of matter in an object. A measurement that reflects the amount of matter in an object. It's basically how many atoms there are in a particular object. Now that's different than weight. Oftentimes we use the term mass and weight interchangeably. We think they mean the same thing. In fact, oftentimes you might even hear me use the term weight when I should really be using the term mass. So if mass is a measurement that reflects the amount of matter in an object, weight includes another variable. Weight includes the gravitational pull on matter. So while the amount of mass in an object would be constant in the universe, so for instance this Apple Pencil, the amount of matter in this object here on Earth would be the same as the amount of matter in this Apple Pencil on the moon. However, the weight would be different because the gravitational attraction for this Apple Pencil on Earth is substantially different than when it would be on the moon. So it would be more appropriate if we use the term mass. Now, the unit that we like to use to measure mass in is the kilogram. In fact, oftentimes in chemistry, we use a smaller version of that mass unit called the gram, and we'll talk about that later. Now, some branches in chemistry are listed here in your notes. The one that we'll spend the most of our time on this year will be inorganic chemistry, and that's in general matter that does not contain carbon. Now, once we get an understanding of general inorganic chemistry, we can then talk about organic chemistry, which contains most carbon-containing chemicals. We will talk a little bit about physical chemistry. We will talk about thermochemistry in this class as well. You can read briefly about each branch of chemistry, their area of emphasis, and the examples of emphasis in your notes. Now, chemists, like most scientists, like to classify things. And so we like to classify matter. And we break it down into two broad categories, and then underneath those broad categories there will be some subcategories. So we have pure substances that we'll talk about first, and the other broad category would be mixtures of those pure substances. So let's first talk about pure substances. Matter with a uniform, unchanging composition. There are two subcategories of pure substances, both of which I believe you've heard of before. They are elements and compounds. Now, an element is a substance that cannot be broken down into a simpler substance. So a substance that cannot be broken down into a simpler substance. For example, everybody's favorite element is gold. The chemical symbol for gold is Au. If I have a sample of 24 karat gold, which is pure gold, I cannot break that down into anything simpler than gold. I have gold. And if I were to try to break that down into something simpler by ordinary chemical means, I could not. I would still have gold atoms. Now, in contrast to that, a compound is a chemical combination of two or more different elements. A chemical combination of two or more different elements. Now, the most common example would be water. As you can see, we have a chemical combination of both hydrogen and oxygen atoms. Two different elements chemically combined together to form a chemical compound, water. Now, these can be broken down into simpler substances by chemical means. For instance, if I pass electricity through water, I'm going to put a little L after this. That means we have liquid water. If I pass electricity through water, we can break it down into its elements. Hydrogen, and the little g in parentheses means gas, and oxygen, gas. I can break this compound down into something simpler by a chemical process. We no longer have the chemical compound water. We have hydrogen and oxygen, which have completely different chemical and physical properties compared to what I started with, liquid water. Now, compounds cannot be separated into their elements by physical means. What does that mean? Well, let's say that I had water, and this time, instead of passing electricity through it, I'm going to heat it up, and I'm going to boil it. Now, of course, when I boil water, I no longer have liquid water. I will have water, but it will be in the gaseous phase. Do you notice the difference between these two equations? In the first, we ended up with something different than what I started with. Chemically, hydrogen and oxygen are different than liquid water. In the second, when I boiled it, which is a physical process, I started with water, hydrogen and oxygen chemically bonded together, and I ended with water, hydrogen and oxygen chemically bonded together, but their physical state is different. One, in the first, it's a liquid, and in the other, it is a gas, but chemically, they're still the same. Okay, more vocabulary. All right, the second broad category would be mixtures. So we talked about pure substances, elements, and compounds. Now we're going to talk about a combination of two or more of those pure substances, in which each pure substance retains its individual chemical properties. Now, there are two kinds of mixtures. There are heterogeneous mixtures and homogeneous mixtures. Heterogeneous mixtures would be a mixture that does not have a uniform composition. So these are mixtures that do not have a uniform composition. They are not uniform throughout. Now, there are two subcategories of heterogeneous mixtures. There are colloids and suspensions. Both, of course, are heterogeneous mixtures. A colloid is a heterogeneous mixture of intermediate-sized particles. So it contains intermediate-sized particles. They do not settle out upon standing. So, let me give you an example. I could have milk, I could have fog, I could have paint as three quick examples. If you have a glass of milk, the particles, the butterfat particles that are suspended in water primarily, will remain suspended. Those particles are so small that they will not settle out upon standing. Now there are bigger particles than milk and the particles that make up fog and paint that will eventually settle out upon standing, and those are called suspensions. So colloids contain intermediate sized particles that will not settle out upon standing. Suspensions are heterogeneous mixtures whose particles will settle out upon standing. So this will contain particles that settle out upon standing. So for example, I could have oil and water mixed together. If I shook up that mixture and let it stand, you guys can imagine that the oil droplets would rise to the surface, and of course the water would be found beneath that. Notice these are both a combination of two or more pure substances, in this case oil and water, in which each pure substance retains its individual chemical properties. I can separate the oil from the water fairly easily. Another example might be sand and water. I could easily separate the sand from the water by filtering it, which we'll talk about in just a minute. And when I'm done separating it, I will still have sand and I will still have water. They all retain their individual chemical properties. Now, if a heterogeneous mixture is a mixture that does not have a uniform composition, a homogeneous mixture is a mixture that does have a uniform composition. So a mixture with a uniform composition. For example, if I put sugar in water and stirred it up, we would have a homogeneous mixture. We could no longer filter out the sugar particles. If I passed sugar water through a filter, I would still end up with sugar water. The particles are so small that they pass through the porous portion of the filter paper. So this would be uniform. It's the same throughout. Now contrast that, if you would, to a suspension where the particles are much larger, and a colloid where the particles are larger, but they're intermediate in size between a suspension and a homogeneous mixture. Homogeneous mixtures are often called solutions. And you probably heard that term before. Another example of a solution would be air. Air is a homogeneous mixture of primarily oxygen and nitrogen. We can't filter out the oxygen from the nitrogen. Now, mixtures can be separated by physical means. There are a few ways to separate the components of a mixture. Number one is by filtration. We can filter out the components of a mixture. Filtration is simply a porous barrier that's used to separate a solid from a liquid. So we use a porous barrier that's an A, to separate a solid from a liquid. So we would use this to separate the components of a suspension. The particles are large enough to where that porous barrier can block them. Now, what about something like a homogeneous mixture or a colloid? How could we separate those by a physical means? Well, we could use distillation. Now, distillation uses differences in boiling points to separate mixtures. So if you can imagine my sugar water mixture. If I boiled sugar water, sugar has a much higher boiling point than water does. So as I begin to heat it up, what will begin to boil first? Of course, the water would be. The boiling point of water is much lower. So the water would start to boil and of course turn to steam, which is still H2O. That steam could then be recondensed. That means I'm going to take it from a gas and turn it back into a liquid. And I would end up separating the water from the sugar. If you can imagine boiling a beaker full of sugar water, or maybe even you've done this at home, maybe salt water in a cooking pan. Once you boil off all the water, doesn't the salt or the sugar remain behind in the bottom of the pan? So one way, or another way I should say, to separate mixtures is by something called distillation. And then finally, another way to separate mixtures is by something called chromatography. We'll demonstrate this in class, but let me just define it for you right now. Here we would use differences in a substance's ability to travel across the surface of a fixed substance. Perhaps you've experienced this when you've used a marker. If you've ever used a marker and your paper got wet, if you touch that marker to a part of the paper that's wet, you'll notice that some of the pigments that make up that marker will travel faster through that water than others. And you can actually see the different colors that might make up that colored marker. For instance, if this were a black dot, the red might travel slower than the blue. And so we can get a separation of those two pigments, a separation of those substances that make up the black dye. So, in conclusion, for your first lesson, chemistry is the study of matter. We talked about what matter was. Go back and review that if you've forgotten. Chemists like to categorize matter, as do all scientists with the subject that they're interested in. For chemists, we like to separate matter into mixtures and pure substances. So, if it can be physically separated from one another by physical means, we call that a mixture. If it cannot be separated by physical means, we call it a pure substance. The pure substances we discussed were either elements or compounds. We define both. Now, if it's a pure substance and it can be chemically decomposed into something simpler, it was a compound. If it cannot be decomposed into something similar, it was an element. If you remember, H2O was the example of our compound, and gold was our example of our element. Now, on the other side of this, if it can be physically separated, we have mixtures. We have either homogeneous mixtures, which we also call solutions, or heterogeneous mixtures. Homogeneous mixtures, if you remember, are uniform throughout. So if the composition is uniform, it's homogeneous. Sugar and water, the air you breathe. If it's not uniform in composition, it's a heterogeneous mixture. Oil and water, sand and water. We said milk was a heterogeneous mixture. We then finally categorized heterogeneous mixture into colloids and suspensions and defined both of those. So, when you come to class next time, make sure you're familiar with this diagram and all the vocabulary terms that we talked about today. Hope you enjoyed your very first lecture. See you in class soon. Bye-bye.